Okay, to the students of Math 1140, this is how I'm going to show you to do a tabulation table to calculate the standard deviation of two quantitative variables as well as their correlation. I start out with a set of x, which is 2, 3, 7, and a set of y is minus 0.04, minus 0.45, 0.7, and 1.4. Okay, and I have calculated the mean here for the x as 4 and the mean of y as 0.55. So the next step is to calculate the so-called deviation. Just take the data and subtract away from the mean. So in this term will be 2 minus 4. That's equal to minus 2. This one is 3 minus 4, and that is minus 1. And this one is 7 minus 4, and that is just 3. Now we go to the deviation of y column. The mean of y is 0.55, so we want to go minus 0.545 minus 0.55. That's actually minus 1, okay? And 0.70 minus 0.55, that's equal to 0.15. And 1.40 minus 0.55, and that's equal to 0.85, okay? And so the deviation of x is 0.2 minus 1 and 3, and the deviation of y is minus 1, 0.15, and 0.85. So right now what we're going to do is take the deviation square, okay? So the deviation of the first term square, so minus 2 square, that's equal to 4. Here minus 1 square, that's equal to 1. Here 3 square, that's equal to 9. Now for the dy square, look at the deviation y column. So you have minus 1, 1 square, that's equal to 1. 0.15 square, okay, that should be 0.0225, and then 0.85 square, and that's 0.7225, okay? And when you sum up these terms right here, the summation of this dx square, that's 4 plus 1, that's 5, plus 9, that is 14. And when you add up these terms right here, summation of dy square, and so you see this term is 0, you add them up, so it's 1.745. Okay? Now, to find the standard deviation, what you have to do is you have to take this term and divide it by the number of data minus 1. And so-called variances of x is equal to 14 divided by 2, and the variances of y is 1.745 divided by 2 as well. And then, of course, you know the relationship between the standard deviation and the variances, which you just take the square root of the variances. So standard deviation of x is equal to the variance of x, and the answer is around 2.65. That's good enough. And similarly, standard deviation of y, following the equation, take the square root of the variances of y, will be somewhere around 0.93. Just round it off to the nearest 2 digits, okay? Now what we're going to do is we're going to do the cross term. So basically you're looking at standard deviation x, the deviation x times the deviation y. So just 2 minus 2 times minus 1, that's equal to 2. Minus 1 times 0.15, that's equal to 0.15 minus 0.15. And then 3 times 0.85, that is 2.55. Okay? And so if you take the sum of these terms, okay, so the idea is you add up all the deviation dx, dy. Now, I will just skip the step and let you know that if you sum up these terms and then divided by n minus 1, as well as the standard deviation here, I'm going to label as xx and sy is equal to 0.93, and divided by sx and sy, you will get a correlation number of 0.89. Okay, so just take the sum of these three terms, add them up, and then divided by the standard deviation x, standard deviation y, as well as the number of data minus 1, and then you will get 0.89. So this is how you do this tabulation table. You could also use a spreadsheet that I gave you and just plug in these numbers, and you will see indeed these are indeed the result that you will get. And to get the fitting coefficient, so-called B1, the slope of the fit, that's equal to R times S of y divided by S of x. And of course, you just take the correlation and times 2.65 divided by 0.93. That's the standard deviation of x. Oh, I'm sorry, I made a mistake. It's 0.93 divided by 2.65. And the answer for this guy would be, the coefficient would be 0.31. Yeah, that's right. Okay, so this is how you do. This is how you use the tabulation table to get these numbers.